Welcome again to another recording. This time it's from May 2022, the higher tier Edexcel maths paper, non-calculator. So this is after a 2-year disruption of COVID-19. This is the first returned paper back to normal, as it were, and unfortunately the examiners haven't pulled any punches. The papers are just as hard and tricky as they used to be, so don't expect any nice treatment. So it's up to you to knuckle down and to try and do the best you can. So on that note, let's work through together, gently at first, question number 1. Question 1, as I say, it starts gently. Solve the inequality 7x minus 27 is less than 8. We can treat this exactly the same as an equation. So treat it as 7x minus 27 equals 8. You'd be surprised how many people get a bit freaked out by the inequality symbol. If that's you, think of it as an equals. I want to have x on its own, so the first decision could be to get rid of this minus 27 by adding 27 to both sides. On the left, we then have 7x. On the right, we'd have 8 add 27, which is 35. We don't want 7x though, we just want 1x, so we need to divide that by 7, and therefore we do the same on the other side. That would leave us with that x is equal to 5, because 35 divided by 7 is 5. However, of course, it wasn't really an equal sign, was it? It was this inequality symbol. So final step, get rid of equals, replace the symbol exactly as it looks, da-dum, da-dum, da-dum. That's the solution. X has to be less than 5. So the first mark's in the bag. Let's get some more marks from question 2. Question 2, write 124 as a product of its prime factors. This is what I tend to call in class a prime factor tree. So you start at the top of the tree with the number itself, 124. We then think, what can we divide this number by? Anything you like, as long as it's divisible, apart from 1. My suggestion would be, if the number's even, you can always half it. So I'm just going to half this one. So 124 divided by 2 is going to be 62. Now what we need to remember is when we get a prime number, we circle it and then move on to the next one. 62 isn't prime, that's still even, so we can half that again. Half of 62 is 31. So we have 2 and 31. 2's prime is 31. Have a little think to yourself, and you should think and arrive at the conclusion that actually, yes, 31 is also prime. Therefore, we've got primes at the end of all these branches, so we're done. So therefore, 124 equals 2 times 2, which we can say is 2 squared, times by 31. And that's it, written as a product of its prime factors, which is what we were asked to do. Hence, we've done the question. Question 3, a delivery company has a total of 160 cars and vans, and the number of cars as a ratio to the number of vans is 3 to 7. So let's just put this into a ratio table. So we've got cars and vans, then let's have space for the total. So for every 3 cars, there's 7 vans. We can add this in, because that's what the question has told us. 3 lots of cars and 7 lots of vans is 10 lots in total. However, we are told that the actual total of cars and vans was 160. So we don't want a total of 10, we need 160. So we need to scale up from 10 to 160. So what could we multiply 10 by to get to 160? We need to multiply by 16. And to keep the ratio in the same proportion, if we multiply this column by 16, we multiply the others by 16. So if we multiply all these values by 16, that's going to tell us how many actual cars and vans we have. So 3 multiplied by 16, that's going to give us 48. This one, you can either do 7 times 16, or because the total needs to be 160, you could also do 160 take away 48. Now that in my mind is easier. That gives me 112. If you want to do 7 times 16, you should get 112 anyway. So you don't need to do it my method, you could just do 7 multiplied by 16. Now we know the total number of cars and vans, we can start to tackle the question. So it says here that 1/8 of the cars use electricity. So we can work out how many cars that is. So 1/8 use electricity. So that means 1/8 of 48 of them. So to find an eighth of something, you divide by 8. So 1/8 of 48 means 48 divided by 8, which is 6. So 6 cars use electricity. It then says that 25% of the cars use diesel. So again, we can work this out. There's 48 cars in total, so 25% of 48. I tend to think of 25% as being a quarter, to be honest. So a quarter of 48 is 12. The rest of them use petrol. So how many cars use petrol? Well, there's 48 cars in total. 12 use diesel and 6 are electric. So 12 plus 6 is 18. So 48 minus those 18 must be the rest of them that use petrol. And 48 take away 18 is, of course, 30. And that's our final answer. Question 4, some standard form. Write 1.63 times 10 to the minus 3 as an ordinary number. It's times 10 to the minus 3, so what's going to happen is this decimal, which is currently here, is going to actually jump 3 places to the left-hand side. So it's going to go over the 1, past nothing, past nothing. Nothing in maths is 0, so it's 0, 0, and then obviously a 0 there, like so. That's almost off the page, so I'll make it a bit neater, like so. 0.00163. If something's in standard form and it's to a minus power of 10, a little trick I tend to use is whatever number comes after the minus tells us how many leading zeros there is before the first non-zero numbers kick in. So we need 3 zeros before the first non-zero number. 1, 2, 3. This one, write 438,000 in standard form. Well, for a number to be in standard form, it needs to be in between 1 and 10. Obviously, this is far too big. So to make this number somewhere between 1 and 10, we'd need to put the decimal place in between the 4 and the 3. So if it goes there in between the 4 and the 3, we need to think where the actual decimal is in the actual number 438,000. Well, 438,000, the decimal goes at the end. So how many digits are in between where the decimal needs to go? It needs to be at 4.38, and where the decimal actually is. Well, there's 1, 2, 3, 4, 5 digits in between, and that tells us the power of 10 we need to multiply by. So our answer in standard form is 4.38 times 10 to the power of 5. And lastly, work out 4 times 10 cubed times 6 times 10 to the minus 5, give your answer in standard form. So even though we've got brackets here, we don't need to think of these as brackets at all. So we can just think of it as 4 times 10 cubed times another 6 times another 10 to the minus 5. Deal with the normal looking numbers first. So normal 4 times normal 6 is 24. And then we can do the powers of 10. So we've got 10 cubed times 10 to the minus 5. This is where we need to remember the laws of indices. Where we're multiplying with powers and the base values are the same, we can work out the new power by adding together the powers. So 3 plus minus 5 is the same as 3 take away 5, which is minus 2. And so the power of 10 is minus 2. And that's 1 mark. We're not done. So we're not done because for a number to be in standard form, it needs to be in between 1 and 10. 24 is too big. So what we need to do is need to change this 24 into 2.4. And to do that, what we've done is we've divided 24 by 10. If we divide that by 10, we've made the value 10 times too small, which is wrong. So to balance it back out again, we need to make this power of 10 1 greater. So if we raise a power of 10 from minus 2 up an extra 1, minus 2 plus 1 takes us to minus 1. And that therefore is our answer in standard form. 2.4 multiplied by 10 to the power minus 1. Question 5, we have a regular hexagon and a regular pentagon conjoined together. Work out the size of angle marked X. So angle X is this one here. I'm going to just colour this in yellow. You must show all your working. So you can't just say what it is, you have to explain why the angle is what it is. So both of these shapes are regular. So we need to know how to work out the exterior angle of regular shapes. And this angle X is actually two exterior angles joined together. And I can show you this by just splitting angle X just down the middle almost, just extending this line here, like so. And then this angle here is the exterior angle of the hexagon. This one here is the external angle of the pentagon. So what you need to realise is that angle X is actually the exterior angle of a regular hexagon here, plus also the exterior angle of a regular pentagon. So to work out the exterior angle of any regular shape, it's simply 360 degrees divided by how many sides the shape has. Hexagon has 6 sides, so each exterior angle is 360 divided by 6, which is 60 degrees. And the same way for the regular pentagon, that's going to be 360 divided by 5. So if you don't know how to do that, I'll just show you the bus stop method again. The answer, by the way, is 72, if you just want to get on with the understanding. So why is it 72? Well, 5 into 3 does not go, so the remainder is 3, which makes us 6 now, 36. 5 fits into 36 7 times. 5 times 7 is 35, which is 1 away from 6, so the remainder is 1. Finally, 5 into 10 goes twice exactly, hence 72 degrees. So therefore, angle X is going to be 60 degrees plus the 72 degrees, which gives us a grand total of 132 degrees. That's the size of angle X, and that's all we need to do. But importantly, like the question says, do show where you get this 132 from. I'd suggest to write down something along the lines of what I've done here, and then show the calculation of 60 plus 72, and also where you've got the 60 and the 72 from, like I've shown here. Question 6, we're going to have to draw a graph. First of all, part A, we need to complete the table of values for this quadratic curve y equals x squared minus 3x plus 1. So there's 3 different ingredients to build what y is. We've got the x squared, minus 3x, and plus 1. So rather than going from what just x is to this whole thing, if you're not that confident with quadratics, or even if you are, I suppose, it might be best to just section out this table into these 3 sections and then build it up step by step by step. So you might want to add in a row for the x squareds, another row for minus 3x, and a final row for the plus 1. So for each x value individually, let's just work out what x squared is. When x is minus 1, x squared is minus 1 times minus 1. Minus times minus is positive, so x squared is going to be positive 1. Over here, by the way, 0 and 1, 1 and minus 1, these coordinates have been given for us, so we can just cross out these. We don't need those. So like I'm saying, x squared for this first one is going to be positive 1. That one and that one we don't need. When x is 2, 2 squared is 4. When x is 3, 3 squared is 9. And then 4 squared for this one is 16. The next row for minus 3x, when x is minus 1, minus 3 multiplied by minus 1, again minus multiplied by minus makes a plus, so minus 3 times minus 1 ends up being positive 3. This one, when x is 2, minus 3 times 2 is minus 6, minus 3 times 3 is minus 9, and finally minus 3 times 4 is minus 12. This final row couldn't be any simpler. Add 1, well 1 is 1 is 1. Plus 1 is always going to be plus 1. So all of these are just going to be an extra 1 on top. So to work out the y value, we just combine all of these ingredients. Y is this x squared and this minus 3x and this extra 1. So this value of y when x is minus 1 is 1 add 3 add 1, which is 5. These two have been kindly done for us. This next one, 4 take away 6 is minus 2. Minus 2 plus 1 takes us to minus 1. this one here, 9 take away 9 is 0, plus 1 gets us back to positive 1. And finally, 16 take away 12 is 4, plus 1 gives us 5. So this is our completed table of values, and if it's a quadratic, you should always see the numbers repeating either side of where the quadratic has a minimum or maximum. So if you look here, minus 1, 1 mirrors with 1, that 5 mirrors with that 5. Part B, we're going to use this table of values to actually draw on the graph of y equals x squared minus 3x plus 1 here. So what we're plotting is just 1, 2, 3, 4, 5, 6 of x and y coordinates, which I'm going to box off in blue. So the first point is minus 1 and 5, so we're just going to do a little point here at minus 1, 5. The next one is 0 and 1, which is going to be here. The next one, 1 and minus 1, so that's going to be somewhere down here. Then we've got 2 and minus 1, which will be here. 3 and 1 up here. And then finally 4 and 5, this point over here. Then, as best as you can, you need to do a smooth parabola that goes through all of these points, and don't do it with a straight line. So this bottom bit shouldn't be a straight line, it should come down, dip down a bit, and then go back up. A parabola has to be curved, something like this, or fairly close to it. And that's part B done. Part C, we're now going to use this graph to find estimates for the solutions of the equation x squared minus 3x plus 1. The graph of x squared minus 3x plus 1, I've done in red here. I can now do the graph of where y equals 0, I'm going to say in purple, and then where the graph of y equals 0, which is just going to be a straight line through the x-axis, where that crosses this red line, will tell us the solutions to this equation. So here's the line y equals 0, and you can see the line 0 and the curve x squared minus 3x plus 1 crosses here and there. So reading the graph as accurate as I can, I make that to be x to be 0.4, and this one is about x equals to 2.6. And those intersections relate to our solutions, so therefore we put x equals 0.4, and the other one, x equals 2.6. If you're plus or minus 0.1 from these values, using the graph of course, you've drawn the graph accurately enough to secure full marks. If you've got x equals 0.7 or something a bit further out, you've not been quite accurately enough, sadly. Question 7, we have two cubes, A and B. Cube A has a mass 81, B's mass 128 grams. It's now talking about the density. Then we need to give our answer in A dot dot B, where A and B are integers. That's just fancy way of saying whole numbers. So how do mass and density relate to each other? We need to remember this. Density is mass divided by volume. We're wanting to work out the density here. What we want to work out, we just cover up with our finger or thumb, whatever, and what's left tells us what to do. We've got m on top of v, so therefore density is mass divided by volume. So for this one here, this cube, the volume of a cube is the length times width times height. So for this cube, it's literally 3 times 3 times 3, which is 3 cubed, so that's going to be 27 cubic centimetres. This one here is going to be 4 cubed, 4 times 4 times 4. 4 times 4 is 16, times by 4 again is 64 cm cubed. So the density of cube A is going to be the mass of cube A divided by the volume of cube A. So the mass of cube A, we're told, is 81. So that's going to be 81 divided by its volume, and we worked out its volume is 27. 81 divided by 27 is 3. We now do the same for cube B. So the density of cube B, mass of B divided by the volume of B. For mass of B, it says in the question, luckily again, it's 128. So that's going to be 128 divided by 64. And 64 goes into 128 exactly twice, so that gives us 2. So therefore, the density of A compared to the density of B equals 3 dot dot 2. And there we have it. That's question 7 done. Question 8. Of a table showing the amount of snow in centimetres that fell each day for 30 days. Work out an estimate for the mean amount of snow per day. So this is a grouped frequency table. Another clue is it's an estimation of the mean. We can't work out the exact mean because we're not told the exact amounts of snow for any particular day. For example, here we're just told it's between no snow at all and 10 centimetres. So you need to remember, what's your best guess for somewhere between 0 and 10, or between 10 and 20 and so on. Now, the best guess, what we have to do is take the midpoints. So here we're going to take the midpoints of these intervals and then multiply them by the frequency. My suggestion would be to extend the table you've already been given, something like this, and then do one column for midpoints. I'm just going to call this MP, and the second one, midpoint times frequency. So over here, the midpoint of 0 to 10 is 5, halfway between 10 and 20 is 15, halfway between these two is 25, 35, and 45. We're now going to times all of these frequencies by the midpoints and total up here. So the first one, 8 times 5 is 40, 10 times 15 is 150, 7 times 25, 175, double 35 is 70, and finally 3 times 45 is 135. The next step is we're going to add up all of these midpoint times frequencies and then divide all of these by the total frequency, the total of all these values here. I put a cross here, do not add up the midpoints, that just gives a nonsense. The total of all the frequencies, just double check and read the question. Is there a quick way of doing this total without making a mistake? If you see here, it does kindly tell you there's 30 days. So the total of all these is 30. Reading the question can save you some work. That's my point here. Read it first rather than just totaling them up and inviting a possible mistake. This here, you're not told. There's no easy way. You need to add these up the old-fashioned way. So let's have a go. So that is not a very nice line, and that's going to upset me. There we go. Right, so nothing plus 5 is 5, plus nothing plus an extra 5 gives us 10. Put for 0, carry 1. 4 add 5 is 9. 9 plus 7 is 16. 16 plus this 7 is 23. Plus another 3 is 26. Plus a carried 1 is 27. Put down for 7 and carry for 2. Finally, 1 plus 1 plus 1 is 3. Plus a carried 2 is 570. So therefore the mean, this means approximately, the total of midpoints times frequency, 570, divided by the total frequency, which is 30. Now, both of these are whole numbers ending in 0, so we can cancel the end zeros. What's 57 divided by 3? 57 divided by 3. If you want to use a bus stop method, you absolutely can, but that gives us 19. So the mean amount of snow, the estimated mean at least, is 19 centimetres. Question 9. We've got a diagram of a cube on top of a cuboid, as shown in this diagram, and it's formed a solid. So the cube has edges of length of 4 centimetres, and this cuboid has dimensions 7 by 6 by 5. Work out the total surface area of the solid. This is a bit nastier than a typical generic surface area question because this is a complex 3D shape. It's basically a combination of two different shapes, one stacked on top of another. So, what we need to realise, the total surface area of this thing is the visible surface area of the cuboid, because not all of it's visible. What I mean by that is this tiny section here is actually hidden from view. So this bit doesn't form part of the surface area because this is actually embedded within the shape. This isn't on the surface, this is on the inside. So for the cube, how many faces are actually visible? All faces apart from this base, which is hidden inside the shape. Normally there's 6 faces with the cube. This one's hidden. That just leaves 5 faces. So think of the cube first. We can come back to the cuboid. The cube's going to have 5 visible faces. And if the sides of the cube are 4, then the surface area of just one face will be 4 times 4, which is 16. So 5 faces, 5 lots of 4 times 4, which is 5 lots of 16, and 5 times 16 is 80 centimetres squared. That's the surface area of the cube, which we can see. Next we need to do the cuboid, and this is a bit harder. So for the cuboid, we've got the front of it and the back. So the front's 7 by 5, and the back has to be the same as the front. So if I just label this on here, that's going to be 7 by 5 times by 2, because it's also the back. We've also got the right hand side and the left hand side. So the right hand side is 6 by 5, and of course, because the opposite faces of a cuboid are equal, this left hand side will also be the same. And then we've got the base, and because I've got a lot of growing up to do, I've just called this the bottom, and I'm going to highlight that in green, and that's 7 times 6. And of course, there's the top of it, but not all of the top can be seen. So we need to work out the visible bit of the top of it, which I'm going to colour in this light blue. Of course, it's not this hidden bit, it's this outer rim without this middle bit here. So let's just think about this with a diagram separately. The hidden bit is basically the shadow of the top of this cube. So the top of the cube is obviously going to have an area of 4 by 4, which is 16. So this bit in the middle, which we don't want, is 16. And the top of the cuboid, the total area for this will be the same as the total area of the base. 7 times 6 is 42. So all of that will be 42. But because we're not including this hidden bit, we need to do 42 take away 16, which gives us 26. So actually, the visible part of the top has an area of 26. Now the front and the back. So the front is 7 by 5. But of course, because we've got a back as well, we need to times that by 2. 7 times 5 is 35. Double that is 70. Then the right and the left, 5 times 6 is 30. But because we've got the left as well, we need to double that, which gives us 60. The bottom's 42, and the visible part of the top is 26. So let's total all this up for the cuboid, or what's visible on the cuboid at least. So 0 plus 0 plus 2 plus 6 is 8. 7 plus 6 is 13, plus an extra 4 is 17, plus an extra 2 is 19. So we have 198. And then we need to add on the 80. So therefore, total surface area is going to be the 198 for the cuboid, plus 80 for the cube. 19 plus 8 is 27, so therefore 198 plus 80 is going to be 278. So the full surface area is 278 cm squared. Question 10. We have a table showing some information about the profit made each day at a cricket club on 100 different days. So here we've got profit and frequencies, and what we need to do for part A is to take this frequency table and convert it into a cumulative frequency table. A cumulative frequency table just means the totals add and add and add until you get to the very total on the end row. But to start off with, the first entry is always the same as the first entry in the normal standard frequency table. So here it's just going to be 10. So we can fill that in. That's the easiest one we can do. So 10 there, therefore we put 10 here. Now we just add these on step by step. So the first one we add is 15. 10 plus 15 is 25. So the next one's 25. Now we add on this number. So we're adding 25 to the existing 25, which gives us 50. Next we're going to add on 30. 50 add 30 is 80. Add on this 5, 80 add 5 is 85, and finally 85 plus this 15 gives 100. And double check, 100 should be the grand total that it says in the question. It is, so you've not made any silly daft mistakes. So that's part A done. We're going to use part A to tackle part B. So for part B, we have to, on this grid, draw a cumulative frequency graph for what we just did in part A. So a reminder for what we had from part A, we had this cumulative frequency table filled in, and we plot these from the endpoints. So we're just using numbers 50, 100, 150, 200, 250, and 300 for the horizontal axis. So we can create these zeros here. I'm just going to cover those all up. So the first one, along to 50, up to 10, then along to 100, up to 25, 150, up to 50, which is going to be here, then 200 along, 80 up, which is this one here, 250 and 85, and the last one along to 300 and up to 100, like so. Now what we need to do is, if we can do, we need to draw through these points with a smoothed curve. If you really struggle drawing a smooth curve, I have checked the mark scheme. You can just do these using straight line segments if you wish, but try and do it as a curve if you can do something like this. And make sure your curve goes through all the points. Really crucial, your curve, it's not a line of best fit, it has to go through the points you've plotted. Part C, we need to use this graph we've just done to find an estimate for the number of days on which a profit was less than 125. So what we need to do here is we read off at 125 and do a vertical line up until we hit the curve we've just drawn, like so. Then once we found the point it hits, we then do a horizontal line from that point so we can read off on the vertical axis. So 125 up and along, I reckon that's about 36. So based on my particular curve, you should have an answer in the region of about 36 days. If you plus or minus a couple of days either side, you should have somewhere between 33 days and about 38 days. The examiner will give you some tolerance if your answer varies from what they think it should be, but as long as you're fairly close to 36 days and there's evidence you read it from the graph, you will secure all full marks. Part D, we need to use the graph to find an estimate for the interquartile range. The clue is in the name, quartile. Quartile sounds like quarters, and so we divide the vertical axis into quarters. So 100 divided by 4 is 25, so the lower quartile we read off at 25, the second quartile is 50, that's the same as the median, and 3/4, 3 lots of 25 is 75. So lower quartile, median, upper quartile. Rather than reading up and along, this time we're going to read along and then down. So the interquartile range is a difference between the lower quartile and the upper one. So we're going to read along and down at 25, which will give us the lower quartile, and then along and down at 75, which will give us the upper quartile. And again, yours might be slightly different to mine, but what you should definitely have at 25 is 100, because that's what the actual table tells us. So the lower quartile is 100, and by my reckoning, reading off at 75 and down here, that's 150. That's halfway between 150 and 200, which is 175, 180, 185. I think mine's about 188. Be as accurate as you can. And again, you might not have exactly the same, but you should have about 100 and 188 on either side. Interquartile range just means a difference between the lower and the upper. So literally, what's the gap in between my 100 and my 188? It's 188 take away 100, the upper take away the lower, Q3 take away Q1, which is 188 take away 100, and of course I make that to be £88. And again, if you're just a couple of pounds either side, maybe £3 or £4 even, but you've evidenced you used your graph to get your answer, and your answer's closest to £88, don't worry if you've not got exactly £88. If you're close and you've used the right method, you will get all the marks. Question 11. Cormac's got some sweets in a bag. How lucky is he? So they're either lime or strawberry or orange. So lime is green, strawberry is normally red, orange is normally, well, orange. So I'm just going to get these colour coded in here, because you've got a ratio. So ratio of lime to strawberry to orange is 9 to 4 to x. So I'll colour code these in the same way as well. So what I would tend to suggest almost all the time for ratios is to do it in a ratio table. So lime, 9 lots, straw, couldn't quite fit on strawberry, apologies, 4 lots, and orange, x lots of orange, and the total of all these was 9 plus 4 plus x. 9 add 4 is 13, so the grand total number of parts is 13 plus x. We're then told that he's going to take at random a sweet from the bag, and that the probability that he takes a lime-coloured one is 3/7. If the chance of him taking a lime sweet is 3/7, that's the same thing as saying that 3/7 of the sweets in the bag must be limes. So that's how we need to interpret this one. 3/7 of them have to be limes. But using this ratio table, the fraction which are limes is 9 parts out of a total of 13 plus x. So 9 over 13 plus x are limes, but also 3/7 must be limes. So therefore 9 over 13 plus x must be the same fraction as 3/7. This is our setup, and from here we can now go and solve it. Now there's a few different ways you can solve fractional equations. What I tend to do is multiply the opposite corners together. If you're wondering why this works, just think of any two equivalent fractions. 5 out of 10 on a test would be half marks. Just double check it. 5 times 2 is 10. 10 times 1 is 10. So this method will always work. If it's one fraction equaling another, I mean. So 9 times 7 is 63. So I can just write equals 63 on the side. And then 3 multiplied by 13 is 39. And 3 times by the x is 3x. So we can now rearrange this and solve. So we need to have x on its own. So if we take away 39 from both sides, we can see that 3x must equal 24. 63 take away 39 is 24. Double check it if you're not sure. Then therefore divide both sides by 3. Therefore 1x would have to be equal to 8. And also this can be double checked. If there's 9 and 4 and 8, then that's 21 parts in total. 9 out of 21 would simplify down to 3/7. So it does work and it can be double checked. Question 12, express 0.1 then 17 recurring as a fraction. I will never forget the time when one of my students years ago thought that these dots were typing errors or smudges. These aren't. These dots mean recurring. So 0.117 with 2 dots above actually means 0.11 and then the 1717 going on forever. And so the tactic here is we just let this recurring decimal be known as little x, or call it whatever letter you want to, A, B, C, but in algebra it's normally x is an unknown. So call x this recurring decimal. Now what we're going to do is to see if we can get these recurring things to eventually cancel. So I'm just going to write this down in a bit more space. So you'll notice here I've got these in a grid. This is just to section it out nice and clearly. So 1x is 0.1171717 and so on and so on. What we're going to do is we're going to multiply x by 10 and 10 again and 10 again and so on until we can get a pattern where we can cancel one row with another. So first we're going to take this and I'm going to multiply it by 10. So obviously if we take this fraction and multiply it by, this decimal and multiply by 10, the dot will move one place to the right. So we're going to have 1.171717. So therefore 10x is 1.171717. I'm stacking these above and I'm making sure the decimals line up. This is absolutely crucial. So do these digits line up? 7's different to 1, 1's different to 7. So these aren't lining up at all. If that's the case, you just go again. So I take this 10x for 1.1717 and times that by 10. 10x times 10 will be 100x, and then moving the decimal one place to the other side, that would give us 11.7171 and so on. So the next step, times it by 10 again, 100 x's must equal 11.71717 and so on and so on. Now, if we have a look at this top row, 100x, and the bottom row, x, you'll see that actually 1 and 1 match, 7 and 7 match, 1 and 1 match, and so on and so on. And that's what we're looking for. When we get some digits that line up, we just do the bigger number of x's take away the 1x. So this 10x now has served its purpose, but we don't need this middle row at all, so I'll just forget that for a moment. We're just going to do 100x take away 1x. So obviously 100x's take away 1x gives us 99x's. And if we start from this end, 1 take 1 cancels, all these others would cancel as well, to infinity. 7 cancels with 7, and so on, and so on, and so on. 7 take 7 is nothing, 1 take 1 is nothing. Now it doesn't cancel, but that's fine. The main thing is you've got rid of the recurring part, and now it's a decimal which doesn't go on forever. 7 take away 1 is 6, 1 take away nothing is still 1, and 1 take away nothing below it is still 1. So 99x's equals 116. Sorry, 11.6. I can't seem to read today. Now, we want this as a fraction. What I'm going to suggest we do is we try to get rid of this decimal. We can just multiply both sides by 10. And if we do that, we can see that 990x's equals 116. Finally, if we divide both sides by 990, we've got what this x is, in other words, the recurring decimal, as a fraction. So divide both bits by 990. We then get that therefore x, which of course is at 0.117 recurring, is going to be 116 divided by 990. Now you might be thinking, do I need to simplify this fraction? Have a check the mark scheme. Interestingly, you don't have to. Normally I would say if you can simplify a fraction, do simplify it unless it's probability. But here actually you can get away with leaving it as 116 over 990. If in doubt, you could actually half 116 and half 990 because they're both even. So you could have also got an answer of 58 over, and half of this one would be 495. But you can actually rest if you got to 116 over 990. That's actually allowed as a final answer. So either this one or that one, job's a good one. Question 13. Fairly nasty in my humble opinion, but hey ho. We've got a right angled triangle here, and it's formed by the diameters of 3 semicircular regions A, B and C. So A, B and C are just different sized semicircles just on the sides of each one of this triangle. We need to show that the area of region A equals area of region B plus the area of region C. So what we need to be thinking of here is actually Pythagoras, because Pythagoras tells us that something squared equals the other one squared plus the other one squared. So what we need to do is think about what we're dealing with first of all. These are semicircles. Area of a circle is pi r squared, so for any general semicircle, the area is going to be half pi r squared. So this is semicircle A, so radius A I've just labelled on here, that's circle C, so r subscript C means radius C, and same for semicircle B. This is what we're trying to show, so our target is to show that the area of semicircle A equals semicircle B plus semicircle C. So putting this in terms of algebra, our target, therefore, is to arrive at this. That is an expression for the area of semicircle A, half of it's pi r squared. This is the area of semicircle B, and half pi r C squared is the area of this semicircle C. Now, you've not been taught this in terms of Pythagoras, but actually we can generalize Pythagoras to any similar shapes. So we could even have similar octagons on either side, and it'd still be area of a big octagon equals the area of the two smaller octagons added together. It's pretty cool. So ultimately, though, you don't really probably care if it's cool or not. You want to know how to answer the question. So the next thing is to just label on the sides. I'm going to label this A as the longest, B and C are the other sides. Start with what we know. Start with Pythagoras. So Pythagoras tells us that A squared equals B squared plus C squared. Just returning to the wording of this question, we're told that these sides are diameters of the semicircles. So this side A is obviously going to be double as long as its radius, because always diameter is double for radius. Side C is going to be twice as long as radius C, and in the same way, side B is going to be twice as long as the radius of B. So we can take this expression and just substitute in that side A is 2 lots of the radius of A, B is 2 lots of the radius of B, and side C is the same as 2 lots of the radius of C. So just substituting in these for A, B and C, we now arrive at this. So 2RA all squared equals 2RB all squared plus 2RC all squared. So if we just expand out these brackets, 2 squared is 4, R subscript A squared is just R subscript A squared. So we get this next. Our target, though, is of course this. So we've got 4s here. We want to have halves. So 4 over what is the same as a half? It's obviously going to be 4 over 8. So what we need to do here is divide both sides of this equation by 8. 4 divided by 8 is a half. So that one gives us a half RA squared equals a half RB squared plus a half RC squared. We're nearly there. What's missing? Well, we need to multiply everything by pi. So the final step, just times everything by pi. And then we can see that half pi RA squared equals half pi RB squared plus half pi RC squared. So that's the area of semicircle A equals the area of semicircle B plus the area of semicircle C. So just to impress the examiner with one final extra piece of working, just conclude by returning to what you wanted to prove. So therefore, the area of A equals area of B plus area of C. That's what we wanted to prove. We have done, so we can sigh a relief. We've done it. Quite an awkward question, but there you have it. Sometimes they can be fairly nasty. Question 14, we have a speed time graph. We need to work out an estimate of the gradient of the graph at t equals 2. So a gradient is normally something you associate with a straight line. Y equals mx plus c, the gradient is m. Here it's not a straight line, it's a curve. So what we need to do is we need to draw a tangent at the point where t equals 2. So we just need to draw the tangent at curve t equals 2, and when we've done that, we then calculate the gradient of a tangent we've just drawn. So t equals 2 is at this point, and a tangent is just a straight line that just scrapes the curve without cutting it at that particular point. So my tangent is something like this. Next, to work out the gradient of this red tangent, I need to just pick 2 nice points I can easily read, then between those 2 points, work out the change in y between them, divided by the change in x between these 2 points. So with black dots, I'm just going to add in my 2 points. I picked that one because it was dead on 0, 1, and this one here was dead on 4, and by my reckoning, that looks like 4.6 to me. So next, we just draw in this line here horizontally and vertically. I tend to do the change in x first, I don't know why. From 0 to 4, that's a change of 4. And vertically, we've gone from 1 up to 4.6. So 4.6 take away 1 is 3.6. We can now compute the gradient of the graph. So the gradient is the change in y divided by the change in x. In our case, change in speed divided by the change in time. So the change in the y-axis is 3.6, and the change in x is 4. Think of it as 36 divided by 4. Well, 36 divided by 4 would be 9, therefore 3.6 divided by 4 is going to be 0.9. You need to have an answer sort of between about 0.7 and 1.1, and of course your answer needs to be based off using this tangent correctly. Finally, what does the area under this graph represent? It's one of these things which teachers might just tell you to know, don't question why, just learn it and memorize it. But you can actually just think about this and sort of remind yourself. Area is obviously two-dimensional. It tends to be a length multiplied by a height or something. So if we have a look at this here, the height is in units of meters per second. And if we multiply this by the units we're going to be using for the length, which is seconds, meters per second times seconds, it's going to come out as being meters. So that's the big clue that this is going to tell us a distance. But putting it simply, the area under a speed-time graph tells us the distance travelled. So all you need to write down is it tells us the distance travelled. And then we're done, and then we're happy. Question 15. A, B and C are 3 points such that the vector from A to B is this 3A plus 4B. The vector from A, but this time going to C, is 15A plus 20B. We have to prove that A, B and C lie on a straight line. To do this, what we need to show is that the direction from A to B is exactly the same as the direction from A to C. If A, B and AC are part of a straight line, it stands to reason they have to be going in the same direction. If one's going in a different direction, that's two different straight lines, isn't it? So how do we prove that they're going in the straight line? To be technical, how do we prove that AB and AC are parallel? Well, there's a must-know fact. If two vectors are parallel, one vector can be expressed as a multiple of the other. So we need to know this. If two vectors are parallel, one can be written as a multiple of the other. And we can do this here, because if you look at AC, AC can be factorised. What we can do is factorise out a 5 from the 15 and the 20, because both 15 and 20 are in the 5 times table. So we can rewrite this as 5, then to get 15A, we have to include 3A here, and to get the 20B, we need to include 4B. And if you notice, we get 3A plus 4B, which is exactly the same as vector AB. And so what we need to show is that AC is 5 lots of vector from A to B. So something we might want to write down could look like this. So like I said earlier, AC, factorise it to show that it's 5 lots of AB. You've then proven that AC is a multiple of AB. So in a sense, you've proven that AC is parallel to AB. We now just need to write this down to show to the examiner we know what we're talking about and we mean business. We want our marks. So since AC is 5 lots of AB, AB and AC are parallel, and also A, B and AC originate, they both start from point A. So therefore, if they start from the same point and are both going in the same direction, they've got to be on the same straight line. Therefore, A, B and C lie on a straight line. And here's a visual for you. So AB is a smaller one, and AC is 5 lots of AB. So from A to C, I've sort of done in like a sort of see-through red, sort of like almost transparent. A to C would be 5 times longer. It's not drawn to scale, but because they're going in the same direction and both starting from A, AB and AC overlap. They've got to be on the same straight line. You don't need to include a sketch. That's just me trying to explain to you why it makes sense. Part B. D, E and F are 3 points on a straight line. From D to E is 3 lots of E plus 6F. From E to F is minus 10.5E minus 21F. But let's just start with imagining D to E. It might help to do a sketch here. So I don't know what vector E is, nor do I know what vector F is. So I'm just imagining E could be going to the right, and let's just say F is going up. As long as we're consistent with our ideas, it'll be fine. This is something of a trick question though. D, E, F, you'll automatically think it means D's here, then E, and then F on a straight line. D, E, and F. But actually it isn't the case. From E to F, because this is minus 10.5E, it's going in the same sort of pathway, but it's going to be opposite direction. So rather than going from left to right, this will be going from right to left because it's minus E. And if I had F going up, minus F's must be going downwards. So from E to F, and you can see these numbers are bigger, so the size of the vector is going to be larger. So actually, F is 10.5 units to the left and 21 units down. Something a bit like this. So actually, the points are in the order F, D, E. It's not in the order D, E, F. It doesn't say they have to be in that order. We need to find the ratio of the length of DF to the length of DE. Now, length can only be a positive thing. You can't have a negative length. You can't be minus 5'10", for example. So we just need to think about the size of from E to F. So what we're going to do here is imagine the distance from F to D. So if I just draw in from F to D in green, and then we can think of the ratio of a green to the ratio of a red, then let's just be thinking, if from here to E is 10.5 units along, from E to D going along is 3 units, I need an extra 7.5 units to get full distance to F. So what we know therefore is that this bit must be 7.5e. 7.5e plus 3e is 10.5e to the right. Also, in terms of going upwards, from E to F is a change of 21f. You could count going down or count going up. So if this is 6f, this must be the extra 15f. So therefore, the size or the length of df is 15e and 15f. We'll return to ratio in a moment, but because ratios operate very similarly to fractions, I'm going to write the ratio as a fraction. So the length of df is 7.5e plus 15f, that's its direction, and the direction of d to e is 3e plus 6f. So these numbers are quite awkward, so what we can choose to do is to get rid of any decimals. I'm going to suggest we just double the top to get rid of that 0.5. If we do that, we need to double the denominator. And so that's going to give us 15e on top. Double 15f is 30f. And on the bottom, just keep that doubled. 3e times 2 is 6e. And 6f times 2 is 12f. Now, what we can see here is both the top and the bottom will actually factorise. So 15 and 30, we can factorise out of 15. And that gives us on top e plus 2f. On the bottom, 6 and 12 are both in the 6 times table, so we can factorise out of 6. So that becomes 6, and then e plus 2f. Now, because we've got a factor of e plus 2f on the top and the bottom, we can cancel that. So we're just left with 15 over 6. And of course, 15 over 6 we can simplify because both 15 and 6 are divisible by 3. So 15 divided by 3 is 5. 6 divided by 3 is 2. So df as a fraction of the length of de is 5 over 2. We can now just put these numbers back into a ratio. So therefore, df to de is therefore 5 dot dot 2. And that's our final answer. Question 16 is about a first aid test, which comes in two parts apparently, a theory test and a practical test. So the probability of passing the theory is 0.75 and so on. But we're talking probability, and there's two events, a theory and a practical. So we can think of it as two steps. In other words, we can think of this as a tree diagram. So first of all, it's possible that someone has the theory test, like so. The theory test is obviously going to be either a pass or a fail. Then after that, they do the practical test, which again is either pass or fail. So it says here, probability of passing the theory test is 0.75. So we could add this in as a probability for passing the theory, 0.75. If you don't pass, then it's a fail. You either pass or fail. All probabilities for any one event add up to exactly 1. And so if this is 0.75, the probability of failing the theory must be the other 0.25. In other words, 1 take away 0.75. So we can add this in as well. The next thing we're told is that the probability of passing only one of the two parts is 0.36. So to pass only one of the two parts can be done in two different ways. We could either pass the theory and then fail the practical, which I'm going to highlight here in pink. The other way of doing it could be that the theory might be failed and then the practical's passed, which I'm going to highlight here in the purple. But as you've noticed here, we're not actually told the probability of passing the practical test. So what we're going to do here, I wonder? Well, we can get it written down like this. So there's a 0.36 chance of passing just one of them. So to pass one of them could be passing the theory, then failing the practical. Or, so we add also the probability of failing the theory or passing the practical. These are the two ways it could happen. So if we sum these probabilities together, it needs to give us 0.36. This would be quite straightforward if we actually knew the probability of passing the practical, but we don't. So what we're going to need to do is think algebraically how we can represent something we don't know. So what I'm going to suggest we do is just let's call the probability of passing the practical test little x. Now, like I said before, the sum of all the probabilities of any one event have to add up to 1. So if there's a chance of x of passing the practical, then the chance of failing it must be 1 minus x, in the same way of the chance of failing the theory was 1 minus this 0.75. Whether this value is here, the chance of failing it will be 1 minus that. So in our case, it'll be 1 minus x. We're also told that the two events are independent. So if this person passes the theory, we've got these probabilities passing the practical, but because passing the practical is independent of the theory, these probabilities will be the same, even if the theory was failed. And so passing or failing in the eventuality the theory test was failed will also be an x and a 1 minus x like so. So we can now input these values and expressions into this formula. And as we should know with tree diagrams, to work out the probabilities at the end, we multiply along the branches. So the probability of passing the theory then failing the practical will be 0.75 multiplied by 1 minus x, and the chance of failing the theory then passing the practical will be this 0.25 multiplied by an x. So if we go from this worded expression to something more mathematically, we can arrive at this. So 0.75 multiplied by 1 minus x plus 0.25x equals 0.36. We can now just expand these brackets, simplify and solve for x, where x is the probability of passing this practical, which is obviously what we want to find. So if I do 0.75 times 1, that's 0.75 obviously. 0.75 multiplied by minus x is minus 0.75 of an x, plus 0.25 of an x equals 0.36. So 0.25x minus 0.75, think about it as 25p, take away 75p, you'd be 50p in debt. So simplifying these x parts, I've got minus 0.50x, in other words minus 0.5 of an x, equals 0.36. I'm going to add this 0.5x to both sides because obviously positive things are just easier to deal with. So if I add on 0.5x to both sides, it'll then disappear from this side, leaving me with 0.75 equals 0.36 plus 0.5x. I want to have all the numbers on one side and the x's on the other. So what we can do next is subtract minus 0.36 from both sides. That then gives us that 0.5x equals 0.36 taken, sorry, 0.75 minus 0.36. If you want to do it the old-fashioned way, be my guest. 5 take 6 we can't do, so we need to borrow one from the 7. 7 becomes 6. The one we borrow moves next to the 5. 15 take away 6 is 9. 6 take 3 is 3. Nothing take nothing is nothing. So therefore 0.39 equals 0.5x. In other words, half of an x is 0.39. So if we now multiply by 2 to get a whole x, we can then see that therefore x equals a probability passing the practical, of course, just remembering what we're wanting to talk about. That's going to be 0.39 multiplied by 2, which is 0.78. So the probability of passing the practical is 0.78. That's our final answer for that one. Question 17, we've got some direct and inverse proportion. So first of all, let's have a look at this first bit. So we're told here y is directly proportional to the square root of t. So the proportionality symbol looks like a fish. Then we put after the fish what it's proportional to. In this case, it's direct proportion. So the square root of t is just this. So we can then take the proportionality symbol and replace it with an equals. So y equals k multiplied by the square root of t. Next, we need to substitute in some values. So we're told here that when y is 15, t is 9. So if we just sub in these values here for y and t respectively, 15, which is y, equals some constant k multiplied by the square root of t, which we're told is 9. We know the square root of 9 is 3, so 15 equals some number k multiplied by 3. So k's got to be 5, hasn't it? Because 5 times 3 is 15. So k equals 5, and therefore we have that y equals 5 multiplied by the square root of t. So that's our first equation. So from here, we've got this. There's another one though to focus on. So we're next told that t is also inversely proportional to the cube of x, and that t is 8 when x is 2. So from this one, t proportional still, because inversely proportional, it means it's 1 over whatever it's inversely proportional to. The cube of x is another way of saying x cubed. So this is just saying that t is proportional to 1 over x cubed, or t is inversely proportional to x cubed. So in the same way as what we did before, we replace the fish with an equals, and we can replace this 1 with not a k, because we've used k before, so instead of k I'm going to pick another letter. I'm going to go for L. If you want to, you could use k again, but that could be confusing. So I'm just picking L, just so I don't confuse it with a k I've already used. So therefore, whoops, it's not a y, so it's a t, my bad. So t equals L over x cubed. We can now substitute in what we're told. So we're told here that when t is 8, x is 2. So if we substitute this in, so when t is 8, x is 2. So x cubed is 2 cubed. So 8 equals L divided by 2 cubed. So therefore, if we multiply both sides by 2 cubed, L must be 8 times 2 cubed. 2 cubed is 2 times 2 times 2, which is 8. So L is 8 multiplied by 8, which is 64. And therefore, we have that T equals L, which we now know is 64, all over x cubed. So now we need to piece these two parts together. We need a formula for y in terms of x. So we don't want this to involve t at all. So if we have a look at this one here, y equals 5 root t. We want it in terms of x though here, not in terms of t. What we can do is we can replace this t with what t is in terms of x. T is 64 over x cubed. So from this one here, in the blue, what we can do is just switch the t for 64 over x cubed. So therefore, y equals 5 lots of the square root of t, which is 64 over x cubed. And it says give your answer in simplest form. So what we can do here, we can actually square root the 64. We can't square root x cubed, A, because we don't know what x actually is, and also square rooting something cubed is quite awkward. But we can just rewrite this as 5 times the square root of 64 on top divided by the square root of x cubed at the bottom. You can split the square root of a fraction into the square root of the numerator over the square root of the denominator. The square root of 64 is obviously 8, so fully simplifying it, y equals 5 times 8, which is 40, all over the square root of x cubed. And that's our finally fully simplified answer. Question 18. Work out the value of this horrible looking thing here, showing all the working. So I'm just going to take this piece by piece. So first of all, let's think of this one. Secondly, 4 2/3. And finally, what's the value of 2 to the power minus 3? Well, first of all, 5 4/9 to the power minus a half. What we can do first is to put this into a top-heavy fraction. So what we can do here is 5 multiplied by 9, which gives us 45, plus the extra 4 on top gives 49. So this is the same as 49 over 9 to the power of minus 1/2. In terms of what we do next, we need to deal with this bottom number of the power, and this bottom number tells us what root we're taking. Because the bottom numbers are 2, we do the square root of both the top and bottom of the fraction. If this was a 3, it would have been doing the cube root and so on. So first of all, let's square root both 49 and 9. The square root of 49 is 7, because 7 times 7 is 49, and the square root of 9 is 3, because again 3 times 3 is 9. So we've done the square root, now we've just got this minus 1 to do. Anything to the power of minus 1 is the same as working out the reciprocal of it. So 7/3 to the power minus 1 is the same as the reciprocal of 7/3, which means we just flip this on its head, which gives us 3/7. So therefore, this yellow one is 3/7. Next, 4 2/3. Just change this to a top-heavy fraction again. So 4 multiplied by 3 is 12, plus 2 is 14. So 4 2/3 is 14 over 3. And lastly, 2 to the power minus 3. Anything which is a minus power, you can think of as being 1 over this thing to the positive power. So 2 to the power minus 3 is the same as 1 over 2 cubed. 2 cubed, 2 multiplied by 2 again is 8. So 1 over 2 cubed is 1/8. So now what we can do is think of this in its simpler form. So rather than having this in the question, which looks pretty horrible, we can just simplify it using what we've done here. So it's the same thing as 3/7 multiplied by 4 2/3, which is 14/3, all divided by 2 to the minus 3, which is 1/8. So this we just simplified to 3/7. 4 2/3 is 14/3, and 2 to the minus 3 is 1/8. So we can now simplify this quite nicely, in fact. We've got a 3 on the top and a 3 on the bottom, so they can cancel. On the top we've got 14, and the bottom here we've got 7. 14 divided by 7 is 2. So the top of this fraction simplifies to 2, and this is still 1/8. So any fraction, like I said before, it's the same as thinking of the fractions being the top value divided by the bottom. So 2 over 1/8 means 2 divided by 1/8. Now think about the rules of fractions. If you're dividing by a fraction, we can keep the first value, change the divide to a multiply, and flip this one on its head. So change the divide to a times, flip 1/8 on its head to 8 over 1. 8 divided by 1, of course, is just 8. So finally, we've got 2 multiplied by 8, which simplifies right down to just 16. And therefore, 16 is our final answer for question 18. Question 19. We have to solve this algebraic equation 1 over 2x minus 1 plus 3 over x minus 1 equals 1. Give your answer in this particular form, where p and q are integers. P and q need to be whole numbers. Now, even though this is algebraic, think of it in terms of numerical. If you're adding two fractions together, we need to have a common denominator. And the best way of doing this would be to multiply by the opposite denominator. So we can multiply all of this fraction here, both top and bottom, by x minus 1. And likewise, this fraction here, we can multiply by the opposite denominator to it, which is 2x minus 1. And so this bit here, we can write as a common denominator fraction. So 1 times x minus 1 is obviously x minus 1. And that's going to be all over 2x minus 1, the original denominator, multiplied by the x minus 1 and timesing it by. Same deal for this one. So I'm going to multiply the top 3 by the 2x minus 1. And the denominator, again, I'm going to be multiplying by the 2x minus 1 from the other side. So the denominator is the original x minus 1 multiplied by the other 2x minus 1. Now, because these now have the same denominator, what we can do is we can combine them into one single fraction. So if I write this all over 2x minus 1, x minus 1, it's going to become this. The top, x here, 3 times 2x is 6x's, so x plus 6x's gives me 7x's. 3 times minus 1 is minus 3, minus another 1 is minus 4. And of course, this equals 1. I'm going to write 1 as 1 divided by 1. In other words, the top is the same as the bottom, and it's equal to this side. So what must be the case here is this numerator must be the same as that denominator, because the top divided by the bottom needs to be 1. So therefore, 7x minus 4 equals 2x minus 1 multiplied by x minus 1. We now need to expand these brackets out. So we've got 7x minus 4. Then multiplying out these brackets, you can use whichever method you prefer. I quite like the box method, so I'm going to do this over here. Create a grid. On the top, I'm going to write down 1 bracket, so 2x and the minus 1. Down the side, I'm going to write the other bracket, x minus 1. So the first one, 2x times x, is 2x squared. This one, x times minus 1, is minus x. Over here, 2x multiplied by minus 1 is minus 2x's. Then finally, minus 1 multiplied by minus 1 is, of course, plus 1. So this fully simplified, we've got 2x squared minus 1x minus another x is the same as minus 3x, and finally plus 1. Now, this is obviously a quadratic equation, and the best way to solve a quadratic equation is to have everything onto one side all equal to 0. So what I'm going to do here is subtract 7x on both sides, and then add 4. Minus 7x, and plus 4 as well. So what we're going to have on this side is 0. On this side, we've still got the 2x squared. Minus 3x minus another 7x is minus 10x's. And 1 plus 4 is plus 5. So 0 equals 2x squared minus 10x plus 5. You might want to try and factorise this, but unfortunately you'd find that it won't factorise. And the fact that the answer needs to be in this form is a hint that it won't factorise, because we're going to have some awkward surds, something involving square roots. If something won't factorise, you can either A, complete the square, or B, use the quadratic formula. What I'm going to suggest we do is to use a quadratic formula. In my opinion, it's easier. So we've got this here. So to solve this, x is minus b, where b is the number in front of the x. So the b here is minus 10. A is the coefficient of the x squared, which in our case is the 2. Of course, that b is also going to be minus 10. And c, the value at the very end, is plus 5. So just using the quadratic formula, we can say that x equals minus b minus 10, which is plus 10, be very careful, plus or minus the square root of minus 10 squared. Minus 10 multiplied by minus 10 is positive 100. Minus times a minus gives us a plus, remember. Minus 4 times a, which is 2, times c, which is 5, all over 2a, which is 2 times 2. So if we just simplify this a bit further, x equals 10 plus or minus. Now 4 times 2 is 8, times 5 is 40. 100 take away 40 is 60. And all of that's over 4. We need our answer to be as simple as possible, so we can actually simplify root 60. This is a surd which simplifies. So is there any factor of 60 which is also a square number? Well, it is. 4 is a factor of 60, so we can split the root 60 into root 4, root 15, and the square root of 4 is obviously 2, so we can place out of 2 root 15. So we've got 10 plus or minus 2 root 15 all over 4. 10, 2 and 4 are all even, so we can half everything. So therefore x equals half of 10, which is 5, plus or minus 1 lot of root 15 all over half of 4, which is 2, and we've got it. X equals 5 plus or minus root 15 all over 2. Question 20. This one and question 21 are very tricky indeed, I think, so let's just try and explain it step by step. So we're talking about a circle here, and its centre is at coordinates minus 1, 3. And point A is also given us coordinates 6, 8. So we're talking about coordinates from the off. So what I'd suggest doing, really, before you even think about the question as a whole, is to sketch on a coordinate grid, something like this. If you do a diagram, it just helps to bring it to life. So now we've got this, what we can do is just sketch on the coordinates minus 1 and 3. So it's a bit to the left of the y-axis and a bit higher than the x-axis. So somewhere like this. You don't need to sketch it dead accurately, just to get an idea of what we're talking about. We're then told that point A, the coordinate 6, 8, lies on the circle. So let's just think about 6 and 8 and add on that point as well on our sketched grid. So I'm going to put 6, 8 here. So if minus 1 and 3 is the centre of the circle, then what we can think about next is what this circle would actually look like. So if that's the centre and 6, 8 is on the circle, then the circle will be going around minus 1 and 3, something like this. So the circle is going to look something like this, in a dotted line I've done it in. So we want to find an equation of the tangent to the circle at A. So we need to remember what a tangent is. A tangent is a straight line that just scrapes the circle at the point where it's a tangent to. So it's a straight line that just scrapes at 6, 8 and goes down again. So the tangent looks something like this. Again, we can draw this on, sketch it on. So you can see already it's got a negative gradient, and we'll cut the y-axis at a positive point and the x-axis at a positive point. So that's the power of the sketch. So let's just think about what we know about the tangent to a circle. So one thing you absolutely must know is that the tangent meets a radius at a 90-degree angle. A tangent and radius meet perpendicularly. So what follows from that, the conclusion, if a tangent and radius are meeting perpendicular to each other, then what do we know about the gradients of two perpendicular lines? What you need to remember is that if two lines are perpendicular, one gradient is the negative reciprocal of the other. So in our case, the gradient of a tangent will be the negative reciprocal of the gradient of the radius it meets. So if that's the centre and 6, 8 is on the circumference, we can draw on a radius and then work out the radius of this one that meets the tangent. So if I just add the radius in a blue line, we can now think about the change in x and the change in y. That's how you work out the gradient. You need to do the change in y divided by the change in x. So think about the x-coordinates. Over here at minus 1, and it goes along to 6. So from minus 1 up to 6, that's a change of 7. And vertically, in the y direction, we've gone from 3 up to 8, so we've gone up by 5. So we can now work out the gradient of this radius. So the gradient of radius, or the gradient of any straight line, is a change in y divided by the change in x between any 2 points. And we've seen here it's 5 over 7. So the gradient of radius is 5/7. We can now use this negative reciprocal idea to work out the gradient of this tangent. The gradient of the tangent will be the negative reciprocal of 5 over 7, so we flip it on its head and change its sign. So the gradient of a tangent will be minus 7 over 5. Let's just think about our end goal. We want an equation of the tangent to a circle. So the equation of a tangent, we want in the equation of a straight line. This looks a bit awkward at the bottom. I'll come to that in a moment. So let's just think about the basics. What's the most basic equation we know of any straight line graph? And I would be saying to you, it's good old y equals mx plus c. So let's just consider y equals mx plus c for this tangent now. M stands for the gradient. We've worked out the gradient of a tangent, that's minus 7/5. So if we sub in minus 7/5 for m, we then get that y equals minus 7/5 of an x plus some c. C is a y-axis intercept here. We don't know what that is yet, so what else do we know about this tangent? Well, we can see here the tangent goes through the point 6, 8. It goes through point A, so we know that on this tangent, when x equals 6, y equals 8. So we can substitute those two values in to this formula. So if we now sub in that x is 6 when y is 8, we get that y, 8, equals minus 7/5 times x, which is 6, plus c. So we can now rearrange this to work out what c actually is. Then when we know what c is, we can tackle this part of the question. So minus 7/5 times 6, well, minus 7 times 6 is minus 42, so that gives us minus 42 over 5, plus c. So we're talking about fifths here. 8 is a whole number. What I'm going to do, I'm going to rewrite 8 in terms of fifths. Well, 8 is 40 divided by 5. In other words, 8 is 40 fifths. So if we do it this way, we can work out what c is in terms of fifths. So to have c as a subject, we need to get rid of this minus 42 fifths. In other words, we need to add 42 fifths to both sides. And when we do that, we'll see that c is going to be 40 fifths plus 42 fifths, which is 82 fifths. So then our equation is that y equals minus 7 fifths of an x, and then plus 82 over 5. We can now think about this here. So we need our answer to be in the form ax plus by plus c equals 0. So everything needs to be on the same side of the equation, and the right-hand side needs to be equal to 0. A, b, and c need to be integers, which basically means they need to be whole numbers that are allowed to be negative. So here we can see these aren't integers, these are fractions. So we need to make these from fractions into integers, so we can get rid of these fifths by multiplying everything by 5. So if we just take this and times both sides of the equation by 5, what we'd then get as our next step is y times 5, which is 5y. Dividing by 5 and timesing by 5 cancels, so we're just going to be left with minus 7x. And 82 divided by 5 times 5 leaves us with 82. We can then get the minus 7x to disappear by adding 7x to both sides. So if we add 7x here and over there, what we're going to have next is that 7x plus 5y equals 82. Then the final step, subtract 82 from both sides, and we've finally corrected it. We'll have that 7x plus 5y minus 82 equals 0. And that's the equation of the tangent to the circle. 7x plus 5y minus 82 equals 0. Question 21. Absolute horrible beast. So let's just unpick this step by step, and even when I unpick it, I still don't think it's that straightforward. But I'll stop moaning and try to explain. We've got 3 circles. Each one is identical. Each has got radius 4 centimetres. The centres of them are A, B and C, such that A, B, C makes a straight line, and from A to B is the same as B to C, which is 4 centimetres. So not only is the radius of each of them 4 centimetres, but the distances between the different centres is also 4 centimetres, which is the radius as well. We need to work out the area of these 2 shaded bits combined, giving our answer in terms of pi. This is absolutely heinous. What I would say, though, is, in my opinion, and there's a few ways of doing this question, the left circle and the right one are almost a distraction. The shaded regions are in this middle circle, so I'm just going to focus on the middle one for now. Now let's add in information step by step. So we're told the radius is 4 centimetres, so we can add this on. That means that from A to B is 4 centimetres, so I'm adding this to both diagrams. Now because this is a circle as well, we know that B, which is the centre of the middle circle, to the edge, that'll also be 4 centimetres. So from B to that part will be 4 centimetres too. So I can add this on. And then just thinking again on this left-hand circle, A is a centre, so A to the edge of that circle over here will also be 4 centimetres, because the radius of all of them is 4. So if I add in an extra line here and label that 4, and the same over here, we can see that, hey presto, what we've got is an equilateral triangle hidden inside this white part. And of course, we know that angles inside an equilateral triangle are 60 degrees, so I'm going to label this one here 60. So let's just think about this equilateral triangle for a moment. Give myself a bit more space, so I'm just jotting over here. Here's the equilateral triangle. We need to know the formula for the area of a triangle. If we know the 2 sides either side of an angle which is known, the area, hopefully remember, is half AB sine C. So in our case, the area of this one is half times 4 times the other 4 times sine of 60. And again, as if the question wasn't hard enough as it was, you got sine 60 and you've not got your calculator to help you. But this is one of these exact trig ratios which you need to know. I'm not going to go into massive depth about how to teach you how to know the trig ratios, but as a very sort of quick reminder, these are the exact trig ratios for 0, 30, 45, 60 and 90 degree angles for sine, cosine and tangent. So sine 60, the sine ratios for 0, 30, 45 and so on are here, and you need to remember that sine 60 is root 3 over 2. So we can replace sine 60 with its exact value in third form, which is root 3 over 2. So I'll say goodbye to this table now, and add in this as being root 3 over 2 instead of sine 60. So the area of a triangle is half times 4 times 4 times root 3 over 2. This can be simplified. So 4 times 4 is 16, half of 16 is 8, 8 times root 3 over 2, basically 8 times root 3 then halved, that's going to give us 4 root 3. So the area of this triangle here is 4 root 3. So I can shade in the triangle in green. I know that area is now 4 root 3, but that obviously is only part of a picture, because in this circle there are also extra bits and pieces we need to work out, like this small sliver here, for example. If I colour that in purple, how on earth could we work out the area of this? Well, we need to consider this as a slice of a full circle which is centred on B. So if I just take this here and jot it out so I can explain it clearly, we've got this here. So we want to work out the area of purple. So what I'm hoping you can see here, if that's a 60-degree angle, and we know that the full degrees in a circle is 360, then this is essentially going to be 1/6 of a slice of a full circle. Whoops. Like so. So what we can reason here is that this slice, including the purple and the green, is 1/6 of a full circle. This, of course, is called a sector. A slice aimed for the middle is called a sector, and so we can work out the area of the purple by thinking of this purple as being the full sector with this green triangle taken away. So this tiny purple slice is the full sector with an angle of 60 degrees minus the area of the green triangle which we worked out just before. A 60-degree slice as a fraction of a full circle is going to be 60 out of a full 360 degrees, which of course we can simplify down to 6 over 36, and both 6 and 36 in the 6 times table, so that becomes 1/6. So this sector is 1/6 of the area of this circle. So it's 1/6 of pi times radius squared. The radius, of course, is 4, so 1/6 pi r squared is 1/6 times pi times 4 squared, minus the area of a triangle, minus 4 root 3. This can now be neatened up as well. 4 squared is 16, and 1/6 of 16 is 16 divided by 6, which is 8/3. So this here is 8/3 pi minus 4 root 3. So written this in its neatest way, I can just say that this purple slice is 8 pi over 3 minus 4 root 3. Now let's look at this circle. By an argument of symmetry, this slice here is the same as this one here, and so on. So we can actually build up this complete circle, including these shaded regions, by just using these purple slices and green triangles like so. So we can think of this whole circle as the shaded bits plus 4 of these triangles, each one with area 4 root 3, plus, if you count them, 8 of these purple slices, where each purple slice has an area 8 pi over 3 minus 4 root 3. Therefore, for the whole circle, the area of the whole circle, which is pi times r squared, pi times 4 squared, because the radius is 4, 8 of these purple slices, plus 4 triangles, plus of course these shaded regions we're trying to work out. So this is going to be the basis of our equation, which we can rearrange and solve, so we're nearly home and dry. So 4 squared times pi, that's 16 pi, and likewise 8 of these slices, we can substitute in the actual numerical value for the area of each slice. Same with these triangles. So if we substitute in the actual values, we're going to have this. 16 pi equals 8 of these slices, each one's got this area, plus 4 lots of 4 root 3, because each one triangle's 4 root 3, plus of course the shaded regions. So we can now multiply out these brackets as our next step for simplifying. So 8 times 8 pi over 3 is going to be 64 pi over 3. 8 times minus 4 root 3 is going to be minus 32 root 3. And 4 times 4 root 3 is 16 root 3. So that's the next step we've got. Again, just to neaten this up ever so slightly, we've got here pi over 3. And here we've got 16 pi. So just anticipating we're going to need to rearrange this, I'm going to rewrite 16 pi as a fraction over 3. So if I just think about that as 16 pi over 1, I can multiply both top and bottom by 3. 1 times 3 is 3. 16 pi multiplied by 3 gives 48 pi. So 48 pi over 3 equals 64 pi over 3. Minus 32 root 3 plus 16 root 3 is overall minus 16 root 3. Plus, of course, the shaded regions. So we can now begin to rearrange this. So if I add on 16 root 3 to both sides, over here and the same here, plus 16 root 3, what we have as our next step is 16 root 3 plus 48 pi over 3 equals 64 pi over 3 plus those shaded regions. Then one final step, and we're home and dry finally. So to get these shaded regions on their own, in terms of an area, we can just subtract 64 pi over 3 from both sides of this equation, and that's going to be, thankfully, our final step. So if we knock off 64 pi over 3 from both sides, we can then see that therefore these shaded regions are going to equal the 16 root 3 and then 48 pi over 3 take away 64 pi over 3. 48 take away 64 is minus 16. Therefore 48 pi over 3 takes 64 pi over 3 is minus 16 pi over 3. And that's our final answer to an absolutely horrendous question. Don't feel too bad if you didn't follow all of that. I think that's particularly nasty. Well done if you did, by the way, of course. And that completes the question, the last one, and therefore the whole paper. Thanks for joining me for that talk through. Hope you found it useful. Please do stay tuned. Hope to see you soon. And please take care of yourselves. So until next time, for Mr. Bailey, it's goodbye from me.